Okay. Good afternoon. So, in the previous class, so not the last class, but in the previous class, we were looking at physical contradictions. And in the last class, each one of us worked on our problem statement to apply different solution finding tools that we had. What I noticed was that for many of you, the problem statement is in itself not clearly defined yet. How many of you have been able to work to clarify the problem statement or to use the tools after the class also? Okay. So now that you started to use the tools, what are your experience? Like, what is your experience? And do you need any input, any support? What kind of challenges did you face? Because applying the tools is not simple. उनको सुनना उनके बारे में सुनना बड़ा आसान है, but when you start to apply them, there are challenges that you face. So after the class, if when you applied the tools, did you encounter something that you need help with?
Sir, technical challenges.
बताओ.
Applying the tools I've done in the class, like step 6, I have used the function oriented search. So in step 6, we have to select out of some 3-4 solutions which we have found from the leading industries. So I have selected one which was focusing on my course on A and B. But then I have just drawn the original RM verifier block diagram and then drawn the modified with the system which we had chosen. But then there were some problems that I was facing. How can we incorporate that system into our systems?
So what I'm hearing is that you have the idea of the new system that you would want to build, and now you do not know how to proceed. Did I understand it correctly?
Yes, sir.
So again, आपने एक नया system बनाया. Now you do not know how to proceed from there. The first thing is make a function diagram. What is the new function diagram? See, you have kind of bypassed the trimming step now. In the trimming step, what do you say is, okay, I have this system. There are so many components in this system, and I want to reduce the number of systems for seeing what can be done. Especially the problem-causing components I want to remove. When I remove the problem-causing systems, then there is a possibility that I will arrive at a good answer. Now you already know, now you're not even looking at what is causing the problem. You're just saying that, okay, I want to have a different system of operation now. A different scientific principle is being utilized, a different mode of operation is being used.
But that is focusing on the root cause. So I am
It is focusing on the root cause, but the function model has changed because the components would have changed.
yes.
So you now need to make the function model.
But in the new diagram, trimming is inherently there. Like
Great.
I have removed the
Function model is not only for trimming. That is what I'm telling you. Function model will also tell you where are the physical contradictions. Function model will also tell you where are the technical contradictions also. Oh, this function is happening insufficiently. Or the cost of this function is very much. You are assuming trimming is already there, but according to your cost constraint, there may be something which is very expensive. And then you may need to do something else about it.
the new system is expensive. Yes.
So, and this is about one system. I'm saying any system that you are working with, once you have a new proposal, again go back to the basics. Start with the function model. This is the consequence of function-oriented search. If you were doing something else, let us say you did not go to the function-oriented search, but you went into the technical contradiction matrix. So what is happening with those of you who are working? So this was about function-oriented search. How many of you are using function-oriented search as of now? As the first solution finding thing or have arrived at somewhere? Is it he faced something? What kind of experience was yours? I don't know.
So like there are it's a quite big. So there are multi layers. They are getting scripted again and again. Like there are big functions of every element. Like moderator is also another function. The field node sometimes have a function. There are control nodes which also slow down and shut down the reaction. So like हर एक function का अपने multi functions देखने को एक function ज़्यादा कर रहा हो ऊपर से pressurize and
So that is the whole purpose of building the function model, na? Because you understand that if I start to trim this component, then all these consequences will happen. And anyways, function model will help you develop a better understanding of the system. So you made the function model, you will need to make that. अगर आप उसको नहीं बनाओगे तो you will again be lost in this so many things. What do I do? See, real world problems are really complex ना, तभी तो आप उस पे ट्रिज लगा रहे हो. अगर वो इतनी सिंपल होती तो ट्रिज की जरूरत क्या थी? You have to make the function model. What about others? यहाँ पे भी कोई था? Okay, so what kind of a technical? So now we are moving to the next tool, which is technical contradiction matrix. How many of you have applied technical contradiction matrix? Okay, आप भी लगा रहे हो. So क्या challenge आ रहा है उसमें?
इसमें आपने कुछ मैट्रिक्स रिलेट की है उसमें प्रेशर पाने का रिलेट हो रहा है अगर उसको नैनो स्ट्रक्चर पे कर देते हैं मेम्ब्रेन को तो उससे क्या है कि माइक्रोप्लास्टिक्स तो रिड्यूस हो जाता है बट उससे क्या प्रेशर जो है वो रिड्यूस हो जा रहा है जिसके कारण प्रॉब्लम है.
So did you apply the technical contradiction matrix? What kind of inventive principles did you get? So you've not applied it yet. My question was, who have applied technical contradiction matrix? What kind of challenges are you facing? तो नजर ही नहीं मिला रहा है कि मैं तो लगाया ही नहीं, मैं कैसे बात जवाब दूं? Is the technical contradiction matrix clear? कोई challenge नहीं आ रहा जो लोग उसको यूज करें? Many of you raise your hand. Yeah, so they had this inventive principle of color change that they got in their inventive principles. So they were like, इसका हम क्या करेंगे? So I said, you can probably do something about it. Color change is, what does color mean? In WebGear, how are different colors different? Why are they different? Wavelength of light is different. So the number of times your ones are coming is different than the number of times your zeros are coming. In a way, if you think of, instead of a sinusoidal wave, you think of a digital wave, number of ones and number of zeros are coming at different frequencies. So color change could be, can I change the encoding of it? See, this laddering you will have to do. You'll have to see how will this particular principle be applicable to my application. Any kind of encoding will change the number of ones and zeros now in your system. So that is like color change for you. Will encoding help you to reduce, let us say, security issues, let us say power consumption, let us say leakage, whatever you are looking at. So जो भी inventive principles हैं, they are very generic in nature. You will have to ladder up to them. So this process is called laddering. जो principle है, उसको आप जिस तरह के examples, whatever examples are given there, आप उसको थोड़ा सा elaborate करो. You elaborate it a little, and then you ladder up to anywhere in that elaboration. That will give you pointers on, oh, I could probably do this. I could probably do that. Are you getting that? For example, you're working on in-memory compute. So Encoding is one of the most common practices that is used for high performance compute. That was right there, actually. Okay, what else? Other people? When you're applying technical contradiction matrix, using technical contradiction matrix, what are you facing? Anything?
So there was one example in the slide where we wanted to improve right stability. So that was the trade-off between stability and
Speed.
speed. Stability and speed. So but then in the slide that we had introduced two PMOSes extra, it is somewhere degrading area. So like this we mentioned, like if we are trying to improve two, like in last class also you were told that there were two parameters that we can take into consideration while applying this. Only after solving that we will be getting what is getting degraded. So at starting only we cannot have all the contradictions listed.
Yes. So what they are saying is that when they applied or we did not really go into much detail of the SRAM example because not all of you are memory designers, and it would be unfair to those of you who are not even in electronics or VLSI engineers. It will be very far-fetched for you. So what they are saying is that in the slides we saw that, okay, you applied one principle and that led to some additional undesired outcome, which was not there, not even listed in the contradiction that you had created. Only when you only when you found a solution did you realize, oh, something else has gone bad, and now you created another contradiction and then another contradiction. So this is what will happen. This we discussed in the last class also. That technical contradiction matrix approach is very simple. You will not even know which parameter is getting compromised in your quest to improve both the target parameters. It could happen there could be a third parameter which is equally important, but now the matrix is only 2D. So that third parameter, to bring that third parameter into picture, you will have to define another contradiction. You'll have another set of inventive principles, and this is a kind of an iterative process. But still, let me assure you, it is far more efficient than searching in the whole 360-degree space. You're still searching with only those 3 to 4 inventive principles and not with everything. So it still is a much more powerful process than hit and try. But physical contradiction in those terms can be far superior. Okay. So any one of you has applied physical contradiction yet? Okay. What was your experience?
First time I went to that space, which is where our project, we have a smart plot model. To do that first, using trimming, we completely eliminated the part. So we just stick with the
Potty hata diya. Good.
Just stick with the sensor part. So we made a clip and can fix to any pot. So
why just a pot? You could be clipping it into any soil near any plant. Okay.
We tried to apply physical contradiction. We feel like we initially came with solar power, so that's not any charge cost per hours. So but while applying that, we figured out parameter change. We can implement both dual solar and also we had a solution also. Either we can move it to products or outdoor one point over, or else we can apply it even for power systems.
Okay. So kya challenge aaya when you tried to use physical contradiction? Was it simple? Did it take time? What happened? So physical contradictions are a leap ahead of technical contradictions. Technical contradiction matrix is just like बच्चों की तरह apply कर देना. To be able to reach to a physical contradiction needs a more in-depth understanding of the system. Okay. So I would strongly encourage all of you to play with physical contradictions also. Okay. uh, what I'm able to make out from the class also is that many of you have not been able to apply any of the tools yet. So some of you have been able to, many of you are not able to. So we will have some practice time today's class also. आप मेरे को छुट्टी देते रहो, मुझे कोई परेशानी नहीं है. But what I definitely do want is that at the end of this course, you should know at least a few tools that you should be able to apply. Okay. So, but let me assure you that whatever concepts I have already shared with you, they already make you eligible for TRIZ level 1 certification. Okay. So TRIZ has multiple levels of certification. TRIZ level 1 तक का content हम already cover कर चुके हैं. जो बचा है वो थोड़ा बहुत मतलब there is sufficient time I can cover that. What I was planning to or what I did cover in my last run of the course was also TRIZ level 2 and even TRIZ level 3 ka content I had started to introduce. But that is entirely up to you. Okay. You want me to go slow, I will go very, very slow. I have no problems. If you're not working after the class, I will have to slow down the class. And those of you who are working after the class, you will really enjoy the slowing down of the class also, because you will have more time to play with the tools. So no one of you will lose, except that all of you will now not be able to go to the higher levels of TRIZ tools. You will not know all of it that I am able to tell you. So it's like, you know, kya kahun? You've you have the possibility to access whole treasure, but you are just going 2 steps deep into the cave and pulling out just what you can see there. You don't even know what all will exist deeper into the cave. That's it. That's all that you're losing, but still you're getting some treasure with you. Okay. So entirely up to you. If you really do spend time on what the tools I have shared, I have many more to share. You don't want to? It's okay. I can also tell you that just TRIZ level 1 certification is more than 50,000-60,000 rupees. TRIZ level 2 certification is more than 2 lakh rupees. And TRIZ level 3 certification, if you want to get it, is 5 lakh rupees. All of that you're getting in whatever 4 credit fees you might have paid to the institute. What profit you want out of it, you have to make. What else can I say? Okay. So I will share the next set of tools. I have gone into more detail than what is required for TRIZ level 1. Okay. Which is fine. I will quickly cover that so that extra details. Okay, आप जब तक आप TRIZ level 1 तक का भी पूरा नहीं करोगे, TRIZ level 2 या 3 के मैं details बता भी दूंगा क्या कर लोगे. So I will skim through the details so that you don't get digressed. And then we'll have some time to implement the tools that we have learned until now, again on our problem statement. Okay? Because again, this is like a new language. I am telling you a new grammar. If you don't practice, there's no point in telling you complex statements and compound sentences and other stuff. There's no point. So we'll go there when you are ready. I don't want to rush you into it. At least the majority of the class should be ready. Abhi, the majority of the class is not there. So we'll keep it slow. And again, it's your choice, not mine. I have all my slides ready. I can go much faster. You want me to go slow. Maybe you're not telling me that by your words. You're telling me that by your action. Okay. So, as I said, I have a vast range of tools that I want to cover with you, but it's entirely up to you. Today, we will look at standard solutions. So, you remember that example of oranges and monkeys, and that example of hydrofoil and cavitation of the. And you remember we talked about substance field diagrams then? We said that, okay, for substance field diagram space, both are exactly the same problem. There are two substances which are interacting with each other in a harmful manner. And because it is the same model in that substance field space, the solution is also going to be the same, which was introduce a variant of either S1 or S2 in between S1 and S2 so that they don't interact directly. That's a buffer zone. And that was what solved both the problems. Remember that? Anyone who does not remember, I can repeat the entire problem again. Okay. So we had looked at this case where we said that in orange orchards in the Mediterranean, monkeys come and spoil the entire orchard because they love oranges. That was one situation. The other situation was that in hydrofoils, which are very, very high speed boats, which kind of have they kind of elevate themselves and then they run over water. So they run at very high speed. What happens is that जो foils hai, because they are in constant touch with froth, which is coming at a very high speed, the hydrofoils ka foils start to cavitate. So you have to go into repair every now and then. And that then, tourist industry, speedboats, motorboats, tourist industry ke liye agar ho rahi hain use, so you lose revenue. Even if it was not a tourist industry, even if it was that you were transporting cargo using these boats or doing whatever, your boat is now not available to you for the period in which it is in the repair shop. So this is again a problem. And we said that there is a same solution for both of them or a same model of solution for both of them because the model of the problem is exactly the same. We said, what is the model of the problem? There is a substance one. Substance one was, let us say, monkeys, and substance two, which was oranges or orange trees. And we said monkeys have a harmful effect or have a harmful action on the orange trees. In the other case, we said there is the substance one, which is water, and the substance two, which is the foils of the hydrofoil. And substance one has a harmful impact on the hydrofoils, substance two. Exactly same model. So Altshuller, what he did was he identified such models from the patents and the problems that he was analyzing. So by this time, when he came to the standard solutions phase, patents वाली story पुरानी हो चुकी थी. He could make out that physical contradictions or technical contradiction analysis cannot give them solutions at all times. And by this time, he had started to develop far better intuition about products and challenges that were being brought out in different patents. And therefore, through that intuition, he was able to arrive at this different language. See, अभी तक हमने किसी नई language की, okay, we have talked about function models, and that is a new English language that we are talking about, a modeling language that we are talking about. But we have not really talked about language of modeling problems. We have modeled systems, but not modeled problems yet. So here he started to model problems now at a very, very high level of abstraction. And he said that, and he was, as he started to build that, उसने कहा देखो इसमें भी यही model था, इसमें भी ये model था, इसमें भी ये model था. So he started to generalize problem statements into models. So all those 2000 patents or more problems that by now people started to report to him. See, क्या हुआ? So he started to work and he started to publicize his work. People started to gather around him. And people started to bring new problems to him. See, I'm trying technical contradiction matrix, it's not working. What should I do? So he was getting corner cases which technical contradiction matrix was not solving. And he started to analyze those cases based on whatever he had already developed in terms of intuition. And he started to now coalesce them into models of problems. And then he said, oh, first, this is the model and this is the model solution. This is the model problem, this is the model solution. This is the model problem, this is the model. And he started to list those things down. And by the way, he was continuing to list those down. Where a point of time ke baad he lost interest. Because now what was happening was that many problems, as they were people were reporting, he could put them onto the remaining, which he had already modeled. Okay. So he could see that it is now a law of diminishing returns. So before that law of diminishing returns set in, he identified 76 model problems and 76 model solutions. That is what is referred to as standard solutions, application of standard solutions. Okay. Now, you may say, okay, I have another one, new one. Yes, there could be. Just that Altshuller soft, uska interest wane ho gaya. His students continued to work. They continued to work and they identified another 9. So there are some places where you will find 85 standard solutions also. Okay. But I have chosen to talk only about 76 here. I'm telling you there are more. And the people are still continuing to add more. But ab dekho, mid 80s mein, he stopped working on standards, further refining standard solutions. He went to other tools, which I intend to cover, which you'll allow me to, I will cover. If you don't allow me, I will not cover. I'm not choosing anything. I know those tools. So 86 में उसका interest kind of खत्म हो गया था standard solutions वाले aspect से. And in the 86 के बाद अभी 40 years हो गए. People not of his caliber or maybe not, or probably his students now with so much experience, they are continuing to work on some parts of it. They've added only 9 more. In the first 10 years, he added 76. People have added 9 more in the next 30 years or 40 years. So, matlab, corner cases hain to aa jayenge, but majority of your problems, 75 solutions should be good enough. 76 solutions should be good enough. Okay. So I'm sticking to this. पहले आप जो अभी तक सीख रहे हो उसकी मास्टरी कर लो. जब यहाँ पहुंचोगे तो अगर आपको बाकी 9 की जरूरत पड़ेगी तो वो भी देख लेना. ठीक है. And just my idea over here is to show you that, okay, this also exists. So that if need be, you can use these tools also. Are you getting it? So what are these? These are standard inventive solutions of 76 generalized models to solutions to engineering problems. Both the generalized models and the engineering problems are formulated as substance field structures. And substance field model represents the problem and the solution through interactions between substances and fields. So basically, kya hua tha? After this, he went into a zone where he said that, how can I help people apply these 76 solutions also? How can they quickly arrive at these substances? So he started to work on the other dimension of problem solving. How to make it easy for them to use these, because these are very, very powerful. Okay. And this was the slide I had used there earlier also, that, for example, in math, you have algebra, chemistry, you have chemical equations, semiconductor physics, band diagrams, coding, C, C++, whatever. Similarly, he said there's a language for inventive problem solving, where there are substances and there are fields. And he also gave a legend, just like we have a legend for function models. He gave a legend for substance field diagrams also, where he said that when there is a desired effect, I will use a solid positive arrow sign. When there is a harmful effect, I will use a wavy sign. When there is an insufficient effect. So similar things. So basically, he did this first. And exactly similar thing we kind of copied in the function model approach. So this legend you almost know. Okay. And the fields that he talked about, so we remember it with the term MATCHEM: mechanical, acoustic, thermal, chemical, electrical, magnetic, optical. So all these fields, he said, are available to you. Depending on the problem that you're working in and the context in which you are working in, you could play with any of these fields. At that time, magnetic and electrical fields were not that common because mostly mechanical industry thi. But by the 80s, electronics industry was also catching up. So electrical field and magnetic field started to catch up. एंड टुडे यू विल सी दैट बहुत सारी जगह पे आपके इलेक्ट्रिकल और मैग्नेटिक फील्ड्स की ही बात हो रही होगी। एंड फिर आपको शायद पुश करना पड़ेगा कि कैन आई समहाउ लुक एट इट एज अ मैकेनिकल फील्ड आल्सो। उस समय people had to push to see if there's an electrical field. It was literally direct. But the idea is that these are various options which you could use even in the solution space. So what is a substance field? So field stands for substance field, which means a system formed by interaction of substances and fields in the engineering system. Substances are components in the engineering system having a rest mass. He's very, very clear about this over here. हमने जब इंजीनियरिंग सिस्टम को पहले एनालाइज करा था, आई हैड सेड फील्ड इज आल्सो अ सब्सटेंस, इज अ कंपोनेंट. बट नाउ ही इज लुकिंग एट दोस कंपोनेंट्स जो हमने कंपोनेंट एनालिसिस करा था, उन कंपोनेंट्स को इज पिकिंग अप वन बाय वन एंड सेइंग does this component have a rest mass? Gravity, does it have a rest mass? No, it's a field. Electricity, does it have a rest mass? No, it's a field. Air, does it have a rest mass? Yes, it's a substance. So substances are components in the engineering system which have a rest mass. Fields a field is similar to energy in some sense. And examples are gravity, magnetic fields, electrical, mechanical, thermal, even biological fields. And an effective engineering system must have at least two substances and at least one field. There can be more substances, but at least two, because every engineering system exists for some interaction, even if with the user, but at least two substances and at least one field, because that interaction could also be happening optically, visually, acoustically by sound, mechanically by touch, pushing, applying force, so many different ways, but at least one way. So abhi hum jab interact kar rahe hain, there are at least two fields which are in play. Optical, you're looking at me, and acoustic, you're also hearing me. So at least एक होना जरूरी है. Are you getting it? Now I'm also recording this session. So in the session, my video is not coming, but the audio still is getting recorded. Audio recording still has some value. You can go back, review what I said, and refresh. अच्छा सर ने ये कहा था. Are you getting it? अगर audio भी नहीं आएगा, do you see the system has completely broken? Are you getting it? So at least one field and at least two substances in a stable, good, functional substance field model. Now, there were 76 solutions. How do you apply them? So 76 उन्होंने निकालते जा रहे थे. And then later, as I said, उनका interest more solutions में बीन होके इसमें चला गया कि how do people use these solutions better? So what he did was, he categorized and organized these solutions into 5 top categories. Classification करी उन्होंने. The first category is building and destruction of substance fields. So in many systems, two substances interact and one substance kind of is dissipated. Or two substances interact, third substances get created. ऐसा होता है बहुत सारे में. या आपके दो substances interact करे तो आवाज आई. Thermite जो आपका welding process है, उसमें two substances interact and heat gets generated. So two substances field. So something is getting created. And these solutions were about, okay, substance field incomplete tha. How do I complete the field? Yeah, substance field overloaded tha. How do I remove unnecessary parts from the substance field? That is category 1. Substance 1 and substance. So substance समझ में आ गया? What is a substance?
Rest other than rest mass.
It is a component in the engineering system with a rest mass. So how many components are there in the engineering system that you are working on? How many? 5, 10, 20, 30, 50, कुछ तो components होंगे ना? So of those components, some of them are substances, some of them are fields. Okay. Now let us say you have picked up a very small part of your engineering system which you want to analyze. And in that, because that is where the problem is, let us say. So now when you are analyzing that system, there are just a few components that you are working with. And those few components have substances and fields. So the two substances that are interacting with each other are the ones that I'm talking about. What I'm saying is that a stable engineering system has at least two substances and at least one field. There can be more substances, there can be more fields, but at least two substances and at least one field. Is this clear? So when that is not happening, that is when the class 1 solutions come into picture because you need to create or complete the substance field. Okay. Second is development of substance fields. So the substance fields exist, but the interactions are harmful or insufficient. So you need to work on them, develop them into stable, positive substance fields. That's a category 2. Okay. Then transition to super system or micro level. So you remember we talked about 9 screens, we talked about फिजिकल कॉन्ट्रडिक्शंस जहाँ पे हमने कहा रिलेशनशिप के अंदर हम लेवल ऑफ इन्वेंटिव प्रिंसिपल चेंज कर लेंगे कहाँ पे आपको सॉल्यूशन फाइंड करना है सो दोस कैटेगरी ऑफ सॉल्यूशंस स्टार्ट टू अपीयर इन थर्ड क्लास फोर्थ क्लास इज एटलीस्ट मेरे एक्सपीरियंस है मेरे को सबसे ज्यादा कॉम्प्लेक्स लगती है फोर्थ क्लास इज अबाउट डिटेक्टिंग एंड मेजरमेंट्स एंड दिस is the most powerful class of solutions in today's world. Everything you want to make intelligent by sensing something and then doing something, is it not? You want to detect something, you want to measure what is the level of that, and then you want to act. आप देखो अपने अपने जो आपने प्रोजेक्ट्स चूज करे हैं सबके अंदर कहीं ना कहीं कुछ डिटेक्शन कहीं ना कहीं कुछ मेजरमेंट है जस्ट रिफ्लेक्ट किसी ने कहा था मैं क्राउड सेंसिंग करूंगा तो क्राउड के अंदर हाउ मेनी पीपल आई हैव टू डिटेक्ट किसी ने कहा मैं सॉइल सेंसिंग करूंगा तो सॉइल में I have to detect and measure something. Detecting and measuring is everywhere today. And this class, therefore, is one of the most important classes. Today, most of the intelligent systems, intelligent products that you would work with, this is what is needed. Those of you who are doing the memory design course, replica paths, all the verifications that you are doing, Six Sigma verification, everything is about detecting and measuring. This class is one of the most important classes. Okay, if you can get a handle of this class itself, आप बहुत सारी complex problems को ऐसे ही solve कर दोगे. And then standards on applications of standards. So it's something like we talked about physical contradiction, and we then said, okay, there's an algorithm, a step-by-step process in which you should ask these questions. So this fifth class is about okay, of these category of things, which one should you apply first? If you see this, then go to this particular category. If you see that, then you go to that particular category. So this is the fifth category. Again, entire focus being on how do I make it easier for people to invent better solutions. See, notice one thing. Altshuller was a super inventor. He had numerous patents, but that was not where his focus was. He had gone to a stage where his focus was, how can I make others successful? Maslow's law of needs. How many of you have heard about it? Just one person. Ooh. So Maslow gave a law of needs. He said that people have needs which they want to fulfill. And there's a hierarchy. The first level of needs are physical, that you need to be able to stand, sit, you need to get food, you need to drink water, clean air, all those are physical. ये सब चीजें होनी जरूरी हैं. Hygienic, good place to sit, clean environment, all that is physical needs. Once you meet the physical, you come to mental, that you should be triggered, tickled mentally. Something new should happen. If that doesn't happen, you will get bored. You will not feel satisfied. Then comes emotional, you know. Then comes, okay. So he just goes along a hierarchy. At the top level, he says, is the need for self-actualization, which means that I'm no longer worried about what happens to me. I'm more interested in how can I contribute to the lives of other people. So Altshuller was at that level now. He was not looking at mujhe kya mil raha hai. I was looking at how can I make others successful. And you will see many people around you who are at that level, at the level of self-actualization, just that you are not aware about it. Think about it. आप भी किसी ना किसी dimension में इस level पे होगे और किसी और dimension में नहीं होगे. So he was at that level and his goal was, how can I make invention making simpler for people? Okay. So let's look at, and okay, this was the listing of fields and the sequence in which you may want to apply those fields. Mechanical, acoustic, thermal, chemical, electrical, magnetic, optical लोग अलग से add कर देते हैं, and you can also add that. But optical, Altshuller said it as electromagnetic. तो electrical और magnetic का mix है, but optical is a very powerful field because for many problems that he also suggested, or the solution that he also suggested to many problems, he would really rely strongly on the optical field. Why? Because for human beings, eyes are one of the most, so brain is, but अगर हम sensory organs की terms में बात करें, eyes are the most advanced sensory organ. See, in terms of taste, many other animals can have better taste buds than you. आपका taste बहुत limited है. Touch, you cannot even sense the weight of air or so many things. There are many other organisms which are more sensitive in terms of touch. Sound is a very limited range. 20 hertz to 20 kilohertz. वो भी आप जैसे मेरे जैसे उम्र पे पहुंचोगे तो 20 kilohertz कम होके 10 हो जाएगा. थोड़ी थोड़ी देर में और बुढ़े होते जाओगे तो 5 या 6 हो जाएगा. आप लोगों का भी कोई बहुत अच्छा नहीं होगा. अभी ज्यादा उछलो मत. There are tests which are available online. आप लोगों का भी 18-19 होगा या 16 होगा. Go do the test. तो आप भी कोई बहुत उसमें नहीं हो. But that's the limited range in which you can hear stuff. Okay. But light, even though you are able to view only a few things, but realize that in terms of colors, in terms of even the spectrum that you are able to see, most other animals can't differentiate between just different colors also. Your eyes are so developed that you are able to distinguish between millions of colors. So for human beings, eyes are one of the most advanced sense organs. So optical is a very important field. He has used it so commonly that he has not even listed it here. But optical, इसलिए जो पिछली वाली slide थी वहां पे मैंने optical लिखा था, यहाँ पे नहीं लिखा. You can add optical field which could be an electromagnetic field. Okay. And याद करने के लिए MATChem. MATLAB कौन-कौन यूज करता है? MATLAB से MATChem याद कर लेना यार. ठीक है. So this was an example that we already saw. Who will relate this example? किसको याद है? चलो बताएगा, आदित्य बताएगा. अरे क्या हो रहा था यहाँ पे? सारे लोग आंखें बंद कर लो, खाली सुनो. इसको शर्म आ रही है.
सर इसमें क्या हुआ था, एक ट्यूब बना हुआ था, उसमें पास कर देते ना वो बाहर निकल जा रहा क्रॉस कर जा रहा तो हमें ऐसे डिजाइन करना था कि क्रॉस ना करें तो हमने ब्रैकेट लगा सकते हैं
छोड़ो छोड़ो, कोई और बताएगा।
stop because the balls were clashing with the pipe. So to stop it, we placed a magnet outside and it repelled.
Magnet repel? So that the collision was Yeah. So the situation was that this was a ball bearing manufacturing plant, and these balls were being manufactured and transported across the shaft floor. There are bends in the pipes. A shaft floor is, just straight nahi jaoge. There are bends in the pipe, and there was natural gravity ki force se the balls were just traveling from one part of the shaft floor to the other. But wherever there are bends, these balls would strike the ball, and after some time, the ball would get ruptured. Once the ball gets ruptured, you have to again repair the ball, and there is a loss of production, clearly loss of revenue. Where it's a if you look at it in terms of flow, it's just a transport process. It's a supporting process. It's not a productive process. And if you're losing some profitability because of a supporting process, that's not really good. So this was to be corrected. And analysis showed that, okay, what is happening is there are two substances. Which are those two substances here? Steel balls and the wall of the pipe. And they are interacting without a controlling field. And if we add a field, we will complete the substance field diagram. And when we do that, what happens? We add a magnet on that side, balls attach themselves to the magnet. Now, when a new ball comes, it would not hit the wall, it would hit another ball. Okay? And the way all the balls will be connected, they will now transmit the pressure onto a much wider cross section of the wall than just one point. So the wall would remain intact. There would still be some cases where a very high energy ball would come and it would just displace one of the attached balls. But then what would happen? Because it has lost its momentum, it will probably itself get disattached to the wall now. Or even if it doesn't get attached, some other ball would come and it would get attached. So the ball bearings are doing self-service. They are protecting the wall from other ball bearings. A very simple, elegant solution just because you looked at it in the model of a substance field and just completed the substance field. This is a category 1, class 1 substance solution, substance field standard solution. Are you able to see this? The other one, the next slide you've already seen, we just discussed that also, where we had talked about the hydrofoils and the monkey, and we said that when there are two substances which are interacting with each other and one of them is interacting in a harmful way, you look at the wavy structure I have shown there, then you add a variant. The variant we added for the hydrofoil was we moved a refrigerant in the hydrofoil so that I have a thin layer of ice. Ice is a variant of water. And if water would come and hit that ice, it would cavitate the ice only. And because I have a refrigerant running, more ice will be created, regenerated. So ice protects the hydrofoil. What was the variant that we looked for in the orange orchards? We had a buffer zone of lemon trees. Lemons are sour. Monkeys don't like them. They think it's a lemon orchard. They don't enter it. And the orchard is saved. And you also sell the lemons, by the way. Huh? So, again, do you see the potential of substance field models? What was the other solution that we talked about for the monkey problem? What is the one that we are using in our campus? हम तो लंगूर की फोटो ही लगा दे रहे हैं बस, नहीं? उस फोटो देख के ही डर जाता है, अब खेलता है उस फोटो के साथ तो समझ गया है, पहले तो डर रहा था. But that was the way, langur was the way that monkeys were thrown out of all the Lutyens Delhi region. नहीं तो जो न्यू दिल्ली रीजन जहाँ पे बहुत सारे गवर्नमेंट ऑफिसेज हैं वहां पे they were infested with monkeys because वहां पे बहुत सारे जामुन के पेड़ हैं, जामुन के, आम के, many big fruit trees, तो monkeys के लिए तो वो heaven है. So there were so many monkeys there that they actually brought in langur to throw them out. Okay. So suppose I want to measure the length of this snake. It's a viper, it's poisonous. What would you do? अगर यहीं पे छोड़ दूं, अनुश्री कह रही है नहीं 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 ऐसा मत करना. How will you measure the length of this snake?
छोटा सा स्केल, छोटा सा मतलब जो फील है और एक फोटो क्लिक लेंगे और मतलब उसी में से मतलब ये ऐसे
इसको पाइप के थ्रू पास करवा देंगे. कौन उठाएगा उसे? उसमें नहीं गया, तुम्हारे पीछे आ गया तो नहीं, मतलब ऐसी मजाक कर रहा हूँ. मोर आइडियाज, व्हाट एल्स वुड यू डू? यही काम की बात. तुम्हें तो अभी मेजर करना है, वो स्किन पता नहीं कब निकालेगा, क्या करोगे तुम? So, let's see what are the standard inventive solutions of class 4. Huh? So the major recommendations of this class are try to change the system so that there is no need to measure or detect. मार ही दो सांप को, क्या करना है? नहीं नहीं. Huh? But try to change the system such that there is no need to measure or detect. That can't happen here because our problem statement is I want to measure how long the snake is. Then measure a copy. A copy could be the skin that it left out. Or a copy could be a photograph with a scale next to it, as he said, where then you somehow say, okay, this is 1 centimeter of photo ko measure karte jao. At least you're not at risk. Replica path and memories, that's a copy. Introduce a substance that generates a field. For example, I want to detect whether a refrigerant is leaking. Suppose I want to detect if there is gas leakage in my home. How do you detect that? Do you know methane is odorless? So what have we done? We have added hydrogen sulfide to it. It has a very pungent smell. As soon as gas leaks, hydrogen sulfide also leaks. And we are able to smell it. So that's a very important principle to detect. Okay, add a small additive, very cheap, but so refrigerants जो फ्रिज के होते हैं उसके अंदर आप एक फ्लोरोसेंट एडिटिव डाल देते हो, थोड़ा सा फ्लोरोसेंट, तो आपको लीक पता करना है कौन से पाइप से कहां से लीक हो रहा है, तो ओके, इन द डार्क इट ग्लोस. So you can detect, oh, this is where the leakage is happening, and so on. Or build a measurement substance field. पूरा एक substance field create करो to be able to measure it. Replica path, for example. Full substance field is created so that I'm able to measure the delay inside a memory. Uh, Canaries. You know about canaries? What are canaries? ये ऐसा वाले चुप हो जाओ. Canaries. Heard about this bird? चलो बता दो फिर तुम.
They are small birds which earlier people used to take to a den or cave. Where, when there is any when there is any bad thing which is about to happen.
अब भूत आएगा तो
इसी particular
So जब ज्यादा गेस्ट आ जाते थे कि तो
So canaries are very little small birds. आपको दिखते भी हैं मार्केट में, you know, छोटे छोटे येलो कलर के birds जो बेच रहे होते हैं. Not legal in the country, but they're still selling. And they have a very loud and very melodious chirp. Coal mines, yes. So what used to be done was, so when people would go into deep into the mines, deep inside the earth, at that place, the levels of oxygen would drop. And coal mines में specifically, अगर कहीं पे हल्की सी भी आग लग जाए, तो ऑक्सीजन जितनी भी थी वो खत्म हो जाएगी और कार्बन मोनोऑक्साइड बनना शुरू हो जाएगा. So lots of accidents can happen. Everyone who is in the mine would die because ऑक्सीजन की क्वांटिटी कम है. और जितनी भी ऑक्सीजन थी पहले कार्बन डाइऑक्साइड बनी और उसके बाद कार्बन मोनोऑक्साइड बन गई. But these birds, they are very sensitive to the levels of oxygen. They need a lot of oxygen because they're very small, छोटा सा lungs होते हैं उनके, and they are very loud and chirping all the time. So what happens is that they need a lot of oxygen, and as soon as the level of oxygen drops in the air, they can no longer chirp. They no longer can sing their song. So miners would take them down into the mine and hang a, what do you say, cage somewhere in the mine where they were mining. And till the time the oxygen levels were fine, they would continue to sing and the miners would get entertained. And because mine तो पूरा इतना लंबा सा टनल है, तो एक भी आपने लगा दिया कहीं पे, तो पूरे माइन में जहां पे भी आपके माइनर्स हैं, they will be able to hear the sound. It's anyway a loud sound and then echo would take it to everywhere. But the moment it stops singing, what happens? You know that the oxygen levels have dropped. And then you evacuate. So you will save all the human lives, though that one little canary is gone. Or maybe not gone, it just stopped to sing and you are able to save that also, we don't know. But that is what a canary system is. So this was a completely new substance field that was created to be able to detect the low level of oxygen in the atmosphere. Are you getting it? So these things can happen and they are done. So here are the 4 recommendations. And then therefore, for a solution, you could use the skin. In fact, that is the way a snake census is done. In zoos or wherever you are kind of nurturing snakes, growing them, that is, the skin is the way that you measure how big they are now. Okay. Or as he said, okay, snake के आसपास एक scale रख दो, ruler रख दो, you will get what does something mean, what does that one particular length mean, and you go about it. Okay. So now I am okay. Okay. So how do you implement substance field diagrams? I'm just giving you a quick introduction. I have not gone into much detail. How do you implement the substance field diagrams or substance field models or use standard solutions? The first step is identify the substances and the fields that you need to work with. So translate your function model into a substance field model. Okay. Then identify which of the generalized substance field problem statements does this model represent. If you are able to relate it to one of the standard 75 substance field problem models, the solution is evident, available there. Now you need to see how to bring that, say, additive substance or intermediary substance, whatever was required, how to bring that into the system now. Okay, and that is where your standard inventive solution becomes as a fastest way to arrive at answers. A very high level, very, very fast way. Okay. Once we made the function field model of a substance field model of that ball bearing factory, did it take much time to arrive at a solution? No. Once we had the substance field model of that orchard problem, did it take long? No. Because solution पता है A या B का substance A substance B का variant चाहिए. तो या तो orange का variant चाहिए या monkey का variant चाहिए. So it becomes very fast to find a solution. It's one of the fastest ways. But it requires laddering up to that level to look at things in that frame of mind. Oh, this is a substance. This is my substance one, this is my substance two. And that is the field. Okay? Sorry? So then you use class one to make the substance field complete. They're not interacting. It means वहां पे वही substance field break हो गया. वही तो first example था ना, जहां पे two substances are interacting without a field. So get a field in there. That's a category one solutions. Category one solutions actually बहुत simple होते हैं implement करना. Because you just either add something or remove something from the system, and it's very fast. Measurement वाला मैं बता रहा हूँ, it's very complex. You saw the guidelines, they're so broad. समझ में नहीं आता कहाँ से copy कहाँ से लाओ. So power I have already explained to you. These are very powerful models. Just 76 of them, and that to organize across 5 categories. So it's not too much of an effort to implement them, but it requires an expertise to be able to visualize components as substances and identify that, okay, this is the field which is insufficient or harmful or this or that. But once you kind of get a handle on your earlier levels, which is function model, and you played with inventive problems, inventive principle, and so on, then this is a natural next step. It does come in easy. Okay. So the keywords that we discussed over here were standard inventive solutions, substance field models, substances, and fields. Okay. So we'll stop here. And I will not add another tool into the kitty yet. Let us spend some time working on our problems. Is that okay? So please rearrange, sit as teams now, and start to analyze your problem and work on use the various tools that we have introduced. Even if you want to use substance field already, please do. आपने कहाँ पे अपने अपेंडिक्स में जो मैंने जो बुक दी थी उसके अपेंडिक्स में देखा था? ओके. So that copying means use cheap copies so that the cost reduces. नहीं, जरूरी नहीं है. हो सकता है cheap copy से आपका काम चल सकता हो. आपका assumption है ना. Many systems cheap copies के साथ work करते हैं. जैसे artificial jewelry है, करती है ना. अगर आपको रात को ही कहीं जा पहनते हैं लोग. क्या बच्चों गोदी में बैठने वाले हो तुम?